When modern institutions attempt to measure their own sustainability, they default to a familiar set of compliance tools, primarily ESG ratings and the UN Sustainable Development Goals. These frameworks all suffer from the exact same structural vulnerability, the arbitrariness problem. Trace their metrics down to the root, and they rest on subjective committee consensus rather than physical laws. By relying on human preferences, these traditional tools measure the surface-level symptoms of extraction. They catalog emissions or diversity ratios, while missing the underlying architectural design failures that actually generate those symptoms. This creates a diagnostic paradox. Evaluating a system's ethics and sustainability is difficult to achieve objectively without the measurement being contaminated by human bias, political ideology, or institutional PR. The Cosmos framework addresses this by establishing an analytical infrastructure grounded in thermodynamic measurement. The methodology operates to 4 specific diagnostic instruments. Every metric and threshold within these tools is derived from universal laws that govern all persistent systems. Thermodynamics provides an empirical baseline for institutional survival. It creates a measurement standard that operates independently of political compromise or ideological capture. The Cosmos framework evaluates human-designed systems against the fundamental design principles found in naturally viable systems, architectures that have survived billions of years of evolutionary pressure. To measure this viability mathematically, we look at a system's computational potential, represented by the Greek letter phi. Computational potential is a system's time-integrated information processing capacity. Systems that endure over long timeframes naturally evolve to maximize this capacity. Violating natural design principles by extracting resources without replenishment or centralizing power to the point of brittleness causes a structural degradation of a system's own computational potential. We can track this degradation through the bedrock of the methodology, the 4 axioms of universal computation. Sustainability is a calculable physics problem. Systems that defy the physical laws of computation face a mathematical certainty of eventual collapse. Axiom 1 requires systems process inputs into outputs. Axiom 2 requires memory substrates to maintain persistent state over time. Axiom 3 observes that viable systems optimize for long-term computational potential, or phi. Axiom 4 identifies that processes must become substrates for higher-order recursion. These 4 axioms describe the absolute requirements for computation to occur in physical reality. Without these axioms, a universe cannot perform processing, maintain memory, or evolve complexity. The conditions that enable universal computation are empirically observable. Because our universe instantiates all 4, we can derive the framework's diagnostic tools strictly from combinations of these axioms. This creates a measurement system mathematically tethered to physics, providing a scientific validity that committee-based metrics cannot achieve. Derived from Axiom 1, Instrument 1 is the 7-element structure, mapping a system's complete anatomy to expose hidden extractive structures. Building on that map, all 4 axioms converge to derive Instrument 2, the 8 fundamental design principles, providing an objective replacement for ESG scoring. There are exactly 8 FDPs because there are exactly 8 distinct ways a system's design can violate the 4 axioms of computation. For example, the principle of symbiotic purpose is a requirement of axioms 1 and 3.
Extractive processing, taking more value from participants than is returned, mathematically degrades the total computational potential of the system's environment. To maintain scientific rigor, the framework applies a worst-case assumptions baseline. Organizations claiming beneficial operations without providing verifiable evidence receive a score of 0 for those claims. The math is further enforced by the dominant pattern priority rule. If over 60% of a system's operational footprint is extractive, it receives a baseline score of 0. Positive outcomes for a privileged minority earn no partial credit, eliminating score inflation. These 2 instruments map what a system actually optimizes for, rather than what its PR narrative claims. Instrument 3 is the Designer Query Discriminator, or DQD. It acts as a survival detection metric derived from axioms 1, 2, and 3. The DQD measures system genealogy. It identifies whether a system's processing roles emerged intrinsically from organic natural interaction, or if they were externally specified and forced upon the participants. This equation maps our 4th instrument, the observer's collapse function, derived from the processing and persistent state requirements of axioms 1 and 2. The OCF quantifies systemic fragility. It calculates exactly what fraction of a system relies on the subjective belief of its human participants to persist, versus what fraction runs on physical reality. The OCF's complexity adjustment uses 3 variables to determine collapse velocity: control stability, feedback responsiveness, and interface connectivity. In August 2025, these metrics were applied to the Doge initiative. The analysis measured extreme centralization and a total absence of error correction mechanisms. This high complexity, paired with low distributed agency, produced a predicted collapse timeline of 6 to 12 months. The system collapsed within 10. Systemic failure is not a random anomaly. When an institution relies entirely on belief, while violating the physical laws of computation, its collapse becomes a mathematically predictable outcome. The Cosmos framework functions like a research microscope. The 4 axioms form the base, while the 4 diagnostic tools operate as the objective lenses. This structural layer is Phase A, objective diagnostic measurement. Because it runs on strict formulas, the measurement process produces identical scores, regardless of who operates the instrument. After the math is locked, auditors apply Phase B, eyepiece filters. These are distinct analytical voices, like systemic critique or scientific epistemology, that provide interpretive context for the objective findings. This separation of math and interpretation allows the framework to evaluate massive global systems without institutional deference. The exact same principles used to audit an institution also apply at the scale of the observable universe. Axiom 2 requires computation to have a persistent state, a substrate that maintains information over time. For this to occur, the substrate must have a relaxation time greater than 0. Photons, traveling at the speed of light, experience no proper time and cannot store memory. A perfectly symmetric universe annihilates into a photon bath, violating the persistent state requirement of Axiom 2. This explains our universe's observed baryon asymmetry. The slight excess of matter over antimatter is the exact value satisfying these axioms, maximizing long-term computational potential. The infrastructure now exists to evaluate our civilization not by subjective committee preferences, but by its alignment with the physical laws that make complex existence possible.